Section 1.2, Functions, Day 2. A piecewise defined function is a function defined by two or more equations over a specified domain. Evaluate the piecewise functions for f of -1 and f of 0. So here we have our first piecewise function where f of x is equal to x squared plus 1, where our domain is x values that are less than 0, and we have f of x equals x minus 1, and our domain is x values that are greater than or equal to 0. So if I want to evaluate this piecewise function for f of -1, I'm going to choose the function that has -1 in its domain. So if I look at the first function where x is less than 0, I know that -1 is less than 0, so therefore I'm going to evaluate using the first function. So f of -1 will be equal to 2. So the value of that piecewise function when x is equal to -1 will be 2. If I want to evaluate this piecewise function for f of 0, I have to choose the function that has 0 in its domain. So I look at my equations. The first one has a domain where x is less than 0. Well, 0 is not less than 0, so I go to the second function where the domain is x is greater than or equal to 0, and 0 is greater than or equal to 0, so we're going to substitute 0 into the second function for x. So f of 0 will equal 0 minus 1, which will equal -1. In our second example, f of x is equal to 2x plus 1, where x is less than 0, and 2x plus 2, where x is greater than or equal to 0. So if I want to evaluate this piecewise function for -1, I look at the two domains that are given, x is less than 0 and x is greater than or equal to 0, and I know that -1 is less than 0, so therefore we're going to substitute -1 into the first equation, and f of -1 will be equal to -1. To evaluate that same piecewise function for f of 0, I choose the function that has 0 in its domain, which will be the second equation. And I have f of 0 is equal to 2 times 0 plus 2, and the value of that function, where x is equal to 0, will be 2. Here we want to graph the piecewise function that's given, f of x equals x squared plus 1, where x is less than 0, and x minus 1, where x is greater than or equal to 0. So we'll take our first equation, f of x equals x squared plus 1, where x is less than or equal to 0, or I'm sorry, just x is less than 0. We'll make our table. We always want to use the value that's given to start with. So 0 is our first value. Because it's just less than 0, that's going to be an open circle on our graph, an open point, because that value of 0 is not included in the domain. Values that are less than 0 will be included in the domain, such as -1 and -2, so those will be closed. When I substitute 0 in for x, I get 1. If I substitute -1 in, I get 2, and if I substitute -2 in, I get 5. I plot these points. 0, 1 is an open circle. And then -1, 2 is a closed circle, and -2, 5 is a closed circle. Now we should know from algebra that the equation f of x equals x squared plus 1 is a parabola. Therefore, when I connect these points, I'm getting a piece of that parabola that exists where my x values are less than 0. For the second equation, f of x equals x minus 1, where x is greater than or equal to 0, Again, I make a table of values. I always start with that given value. This will be a closed circle because it has an equal sign. That value will be included, as will values that are greater than 0 be included, such as 1 and 2. We substitute these values into our equation. We plot these points. And we should also know that the equation f of x equals x minus 1 is the equation of a line. We're going to draw the piece of that line where my x values are greater than or equal to 0. Note here says piecewise functions must pass the vertical line test. So you can see that if I draw a vertical line through this graph, it's only going to hit this graph in this closed circle point of 0, -1. The open circle point of 0, +1 is not included in the graph, so therefore it passes the vertical line test. Here we want to graph this piecewise function. F of x equals 2x plus 1, where x is less than 0. We'll start with this. So 2x plus 1, x is less than 0. We'll start with 0. Again, open point. Values less than that, -1, -2. Substitute those. 0, 1 will be an open circle, -1, -1 will be a closed circle, and -2, -3 will be a closed circle. This is the equation of a line, so we're going to draw the piece of this line where my x values are less than 0. The second equation, f of x equals 2x plus 2, where x is greater than or equal to 0. We'll start with 0. That's the given value. This will be closed. Values greater, such as 1 and 2, we'll use. And we'll plug in, or we'll plot these points rather, 0, 2, 1, 4, and 2, 6. Again, this is the graph of a line. This line will draw the piece of this line where my x values are greater than or equal to 0.